Today we're going to talk about the 6 basic trig functions and their graphs. We have some information that we're going to go through, and then we are going to actually graph the functions. And for your homework over the next couple of days, you will have to draw the graphs on a lot of things. So this is your cheat sheet. You will be able to use it on your test to give you an idea of what they look like, but you will have to draw graphs. So, a couple things to keep in mind. Make sure your x-axis is always labeled in radians. Everything from this point forward must now be labeled in radians. Please make sure you pay attention to that. So the first one we're going to talk about is sine. And last time in class you went through a noodle activity to unwrap the unit circle and saw how the values on the unit circle related to the graph of sine. If you remember, our period is 2 pi, because that is one complete revolution around the circle. The domain in this case, all of my x-coordinates go from negative infinity to infinity. But our range, remember the radius of the unit circle is 1, and so our range is actually stuck between negative 1 and 1. Now, zeros for sine happen at every pi. So they happen at pi, 2 pi, 3 pi, 4 pi, so we have to have a way to denote that. And mathematically, we're going to write that as plus or minus k times pi. And k is any integer. An integer is a positive or negative whole number. So any positive or negative whole number times pi is going to be where my zeros occur. Alright, so this is some of the basic information for sine. Now we're going to take a look at the graph. As I stated before, first thing we need to do is label. So we want to put a 1 and a negative 1 on our y-axis. We're going to talk about our 4 basic points. That is 90 degrees, 180, 270, and 360. But we have to label things in radians. So, when we do that, we have pi over 2. Then we have pi, 3 pi over 2, and 2 pi. And to the left, we're going to go ahead and label negative pi over 2 and negative pi, just because we're going to take a look at what happens when we go counterclockwise around our circle too. So now, as I'm going around here, remember we're talking about the sine of x, so that's the y-coordinate. When I start at 0 degrees, my y-coordinate is 0, so that's where my point goes. At pi over 2, my point is, my y-coordinate is 1. At pi, my y-coordinate is 0 again. 3 pi over 2, I'm at negative 1, and then at 2 pi, I'm back to 0. So my graph has a nice curve, and it is a curve, not a V. These are not straight lines, so make sure you curve your graph. And this value from 0 to 2 pi is what we call one period of the graph. So this is what one section, if I go one time around that circle, this is what one section of my graph is going to look like. Now if I go the opposite direction, remember if I go negative pi over 2 is the same as 3 pi over 2, so I go down. At negative pi, I'm back up to 0. And you can see how our graph's going to keep going and going and going. It's going to follow the same pattern all the way through because it's like going around the circle multiple times. So if you need to pause the video, make sure you have all of this written down correctly. Remember, you will be able to use this sheet on your test, so make sure you have things written correctly. Next, we are going to talk about cosine. Cosine is all x-coordinates on the unit circle. Our period is still 2 pi. Our domain is negative infinity to infinity. Alright, range is going to stay the same because once again we are still on the unit circle, so our radius is 1. But our zeros are a little different. For cosine, the zeros happen at every pi over 2. So what we do is we talk about pi over 2 is where my first one is, and then it happens plus or minus k pi. So it happens at pi over 2, 3 pi over 2, 5 pi over 2. So every other pi over 2 is where that happens. So if I add a pi to everything, I'm going to get those zeros. So now we want to go through and we want to go back and label our graph once again. 1, negative 1, pi over 2, pi, 3 pi over 2, and 2 pi. Right, make sure you go with your negative values as well. Negative pi over 2 and negative pi. So we'll look at a little bit of that. And now think about the cosine. At 0 degrees, my cosine value is 1. So I'm up here for the cosine is where I start. Then as I go around the circle, I go to 0, -1, 0, +1. And this too is a curve. So make sure you draw your line as a curve and not a bunch of straight lines. And this is what we call one period from here to here of the cosine function. If I go -pi/2, that means I went down. Okay. And then at -pi, I'm down at 270 degrees or -pi. And you can see our graph looks like this for cosine. So it's just a little shifted from the sine function, actually. It shifts only about pi/2. So take a second, double check your work on cosine, pause the video if you need to, and then come back. We're going to start with tangent. The tangent graph. Tangent's a little different because if you remember, tangent is sine over cosine. So we're going to run into some trouble. If you recall from our rational expressions unit, I cannot divide by 0. So anytime that the cosine is going to be 0, I'm going to run into trouble. If I back up a second, I notice cosine was 0 here at pi/2 plus or minus k pi. So it happens a lot. So because the cosine is 0 there, those are values I have to leave out of my domain. Can't have. So the period for tangent is actually pi. It repeats every distance of pi. Now, how we write our domain, because we have to leave out all those zeros for cosine, is we say reals except pi/2 plus or minus k pi. Okay? So reals except pi/2 plus or minus k pi. So we throw out all of those zeros. Now, our range is going to be a little different because we run into all these asymptotes, and remember, asymptotes are things that as we go to infinity, we get closer and closer to, but we can't actually get to. So our range here goes from -infinity to +infinity. Alright? We do have zeros for tangent, and the zeros are going to happen when the sine was 0. If you recall from where the sine was 0, if you look up at the top of your paper, it was 0 at plus or minus k pi. Now, asymptotes are values that we leave out of our domain. Those are our vertical asymptotes. And so here, because we left out pi/2 plus or minus k pi from our domain, those are going to be our asymptotes. So let's take a look at the graph. Alright. First off, as with every other time, draw your labels. Pi/2. Pi, 3 pi/2, 2 pi. Come on over and draw the -pi/2 and the -pi again. Now, when we do this, we got to make sure we get those asymptotes filled in. Alright, so we said all of the asymptotes are going to happen at pi/2. So I draw my first one in at pi/2, draw a dashed line, dash vertical line because it's a vertical asymptote. Then I add a pi to that, which gets me a 3 pi/2. So I'm going to draw another vertical line here. I'm also going to have one at -pi/2. So you see how I have all these asymptotes hopping in over and over and over again? Now on this, our zeros were in between those asymptotes. So at pi, 2 pi, I actually get one over here at 0. And I have one at -pi. I could add in another point over here, which would be 5 pi/2, so that I can continue on and see a full period. Alright, when I go to draw my graph, tangent is an increasing function, so it goes up over the entire distance. So between each of the asymptotes, my graph is going up. And it kind of looks like an x-cubed graph to some extent. It's got a similar shape, but that is what your tangent looks like. Okay, now one period of the tangent would be from pi/2 to 3 pi/2, so that distance in between those two asymptotes is what we consider one period of this function. Okay, So as before, take a second if you need to, pause the video and come back and make sure you have all the information for tangent. Next, we are going to talk about cosecant. So the reciprocal functions are kind of interesting because what happens is we know cosecant is equivalent to 1 over sine x. Well, now we run into the same problem we just did with tangent, is that we're going to have some asymptotes. And those asymptotes are going to occur everywhere that I have a 0 in the denominator, and that, for sine, is at k pi. So my period is 2 pi, it still follows the sine function, but now on that domain, we talk about all reals except what's going to make the sine 0, and what makes the sine 0 is that plus or minus k pi. Our range now on these, because of these asymptotes, we know we're going to have something fishy going on, we got to go to our infinities. Well, it actually leaves out all of the values of the actual sign, so I can't be in between -1 and 1. So my range goes from -infinity to -1, has to leave out the rest of it, and it doesn't start again until 1, to infinity. And we'll kind of show you on the picture, it makes a little more sense. So because I can't be between -1 and 1, I have no zeros. And once again, I left values out of my domain, so those are my vertical asymptotes for this guy. So if we go over here and we're going to draw our graph. Alright, make sure we label. Now, once I have my labels, we need to draw in our asymptotes, and remember our asymptotes were at every pi, so I got an asymptote here, and you do need to make sure on your homework assignments and your test that you draw in your asymptotes so we know that you know where those are, that you were paying attention to this part. Now we don't have any zeros, so it's hard to figure out where do these other values go. Well, what happens is that at pi over 2, if I type in 1 over the sine of pi over 2, I actually get 1. Okay, because the sine of pi over 2 is 1, and the reciprocal of that is still 1, so I have that value. Now, because I am positive, this graph is actually going to go up, and it kind of ends up looking like all these weird little parabolas. At 3 pi over 2, I'm at -1, and my graph goes down. At 2 pi, got nothing on that side. Over here to the left, at -pi over 2, down here again, which makes sense that these guys are coterminal angles, -pi over 2 and 3 pi over 2, so they should look the same on the graph. Now we talked about one period. One period of this is still 2 pi, so this whole thing. So I need a upside parabola and a downside parabola for that guy. And that is one period of the function. So what's cool about these, though, is that if you know your sine and cosine, coming up with secant and cosecant, as long as you know which one is the reciprocal of the other, you can actually come up with the graph. So we said cosecant was the reciprocal of the sine function. Well, I could sketch in the sine function here in blue, and notice everywhere it was 0 I have an asymptote, and then wherever I had a max or min on my sine is where my max or min is for my cosecant. Now, please, please, please do not make sure you do not put that on your 6 basic graphs, because it is not part of the graph. You'll need to make sure you leave that off when you're drawing these. So do not put in the sine or cosine on there when you're drawing it on your sheet here. But that's just to give you an idea of where those come from. Just go ahead and check out cosecant. Pause the video if you need to, and come back, and we're going to move on to secant. Secant is very similar to cosecant because it is 1 over cosine. So the period is still 2 pi. My range stays the same at -pi, or -infinity to -1. For the same reasons, I leave out the middle. Right? I still don't have any zeros. But now my domain is wherever cosine is 0. And so those are the things I have to leave out. Reals, except, remember, cosine is 0 at pi over 2, plus or minus k pi. That's what I'm leaving out. So those are also my vertical asymptotes. Okay, let's go ahead and draw our graph. Make sure you label your axes. And once you got your labels, let's go ahead and put those asymptotes in. And remember, we're going to put these now at every pi over 2. So dash vertical line at every pi over 2. And we're thinking about where are the ones for cosine. Well, here at 1, my cosine graph actually started at 1. And it's up, so my graph's going to go up. At pi, I'm at -1, so my graph's going down. At 2 pi, I am at 1. And I'm only looking at half my graph. And you can see how this is going to repeat as well. Just go ahead, pause the video, make sure that your graph is correct, you have all the information, and come back and we will talk about cotangent. Our last graph is the cotangent. Cotangent is a reciprocal of tangent, so instead of sine over cosine, it is cosine over sine. These were your properties that you had to know in the last section. We will use these a lot moving forward this semester, so please, please, please make sure you understand those. The period for tangent was pi, so the period for cotangent is also just pi. Now, the domain here is going to leave out wherever the sine is 0, not cosine. So it is reals, except plus or minus k pi. Right, my range for tan and cotan is -infinity to infinity because of all those asymptotes. My zeros are wherever the cosine is 0, and we just said cosine was 0 at pi over 2, plus or minus k pi. And my asymptotes for this one, and your paper may not have asymptotes there, the line for that, so go ahead and write it in if it is not there. But I have asymptotes at plus or minus k pi. Alright, now let's go ahead and draw the graph. Make sure you put your labels in. Once you get your graph labeled, go ahead and draw in your asymptotes. Remember, these are happening at all the pi's, which also makes the y-axis an asymptote. Okay. And now our zeros are going to be in between our asymptotes, just like they were for tangent. This is the reciprocal, which is a flip, so we flip our graph over. So cotangent actually goes down. The decreasing graph still has a similar shape, just goes down. Go ahead and check both of these, and then we're going to fill in the very last part. Pause the video if you need to. General form of sinusoid. So this helps us talk about describing transformations. And when we describe transformations of our trig functions, we're going to get into that a lot over the next couple of days. Please make sure that you think about your transformations for all of your other functions. A lot of the things remain the same. So y equals a sine bx plus c plus d is our general form for a sinusoid. A, which is also known to us, let's use a different color here. A is our vertical stretch or shrink, but it is called the amplitude. And amplitude is our big word of the day for that, amplitude. And you'll notice right under this we have amplitude, and that is the height of the max and minimums from the x-axis. So how tall are the peaks and valleys on my sine and cosine graphs? Okay. B is my horizontal stretch or shrink. And it also denotes a period change. So it tells me how much my period changes by. And this is going to be a pretty big deal actually on that one. And then C is a left or right shift. D is an up-down shift, just like we did before. That doesn't change. So we're just changing the name of A and B a little bit. We're talking about amplitude, we're talking about period change. Period change has a formula. The formula for period change is the period of the parent graph divided by B. And that will give you the period of the new graph. You need to write that next to it. New period equals the period of the parent divided by B. And we will use these a lot over the next couple of days. That is all I have for you today. Thank you. If you need to, go back and watch certain parts of the video. Make sure you understand and have all of your graphs written correctly on your paper.